over Iyy z minus by mz over Izzzy. Okay. So the confusing part comes when there is a find the orientation of the neutral axis. Okay. So if we were to draw a structure, the cross section of a structure, okay, this is the cross section of a structure. And I always insist that this axis over here right? The y and z, y and z are fixed to the structure. Okay. So what do I mean by that is if I take the whole thing and if I rotate this by, I'm going to paste first. Okay. And if I'm going to rotate this by 45 degrees, the x and y will rotate likewise. Okay, will rotate likewise. Okay. So this is very important. Why this is important, why the y and z is rotating is because it's easy to find the second moment of area. Like for this case, right? Iyy and Izz at this orientation, and Iyy and Izz when you rotate in a different orientation, but the transformation rotate with it. Both Iyy and Izz at the top and the bottom example have the same value. Okay. And that is important because it simplifies how we find our second moment of area. Okay. So if you were to find Iyy and Izz based on this orientation, it'll be more difficult. Let's say we insist that our y and z is fixed to the free space. Okay. Then it's difficult to acquire Iyy and Izz. Okay, so it's rotating the structure. Then going back to finding the position of the neutral axis. Okay, so we know that at the neutral axis, right? At the neutral axis, and we already know that the neutral axis is different from the centroid, right? Is that stress x is equal to 0. So I call this equation 1. So therefore, equation 1 becomes, right, becomes 0 is equal to my over Iyy z minus by mz over Izzz y. Okay. Then we arrange the equation. So we have mz over Izz. Hey, Izz, come on. Izz y is equal to my over Iyy z. Okay. So now if we were to have a a moment vector, right? So let's say that now this is our moment vector. Okay, this is our moment vector. And our moment vector is rotated anti-clockwise. Sorry, clockwise from Z, and we're going to call this theta. And we're going to call that theta. Okay. Okay. So M will have two components. One, moment about the z-axis, right? So we have one moment over here. Sorry. So we know that this is our moment about z-axis. And then we have another one. This will be moment about y. So from here, we can write out an expression that we can specify that tangent, we can specify tangent theta, right, is equal to my over mz. Okay, we can write out that expression over there. Okay, so the first one, this is derived. So this is our equation 1a. And for this case, right, we also know that going positive is in the clockwise direction from the axis. It's important. We have to know that this is from the z-axis. Okay, so this is our equation number 2. Okay, so from equation number 1, 1a, sorry, if we rearrange the term y over izz is equal to my over mz, right, z over iyy. So again, this is I'll call this our equation 1b. Okay, so we substitute equation 2 into equation 1b, right? We will have the expression that y over izz, right, is equal to tangent theta z over iyy. Okay. Then from here, we are going to have a neutral axis. Okay, I'm going to draw a neutral axis. So if this is our neutral axis, orientation of our neutral axis. Okay, this is our orientation of our neutral axis. Our neutral axis will then have anti-clockwise. Okay, from Z again, and this is our pi. Okay, and at this point over here, we have a z-axis, a z coordinate, and a y coordinate point. Okay, so this height over here, right, this height I'm drawing now, that is for your y, and this orientation over here, this is for your z. Then we can write out another expression. Okay, I'm going to move this to a side so I can free up more space. If I could do that, yep, I could do that. Okay. So we know that tangent, okay, we know that tangent pi is equal to y over z. And also, positive is in a clockwise orientation from z-axis. Okay, so that is our equation number 3. Okay, so we are going to, so this is our equation 1c. So we are going to substitute equation 3, right? We're going to substitute equation 3 into equation 1c, right? So if we look at 1c, we can rearrange it to be y over z, and this is equal to tangent pi, or tangent theta, sorry, is equal to izz over iyy, right? So y over z we know is equal to tangent pi is equal to tangent theta iyy over izz. Okay. So a lot of times students are confused is because of they could not remember that this axis is fixed to the structure. Okay. So I will now do a example now. Okay. Is anyone need to clarify anything, or are you okay? I think the most important part is I want you to see like how this is derived. Okay. And it's not difficult. All you need to do is this formula is provided, okay, and you just need to remember how to draw this diagram. Okay, these are the key points. Okay, so from here, let's look at an example from your homework. I hope to find, I think it's homework number 2, I think. Okay, let's look at this example, and I'm going to not just look at this example, okay, and I'm also, what if we change something, what will happen? Okay, so I'm going to take a snapshot of this. Where is my, okay. So this is the orientation of our structure. Okay, so okay, so we are asked to find, right, determine the angle of the neutral axis. Okay, so the formula we're going to use, which we just derive out, is equal to tangent pi is equal to izz over iyy tangent theta. Okay, So we are aware tangent theta is relative to the applied moment. So which is the axis? Okay, which is the axis? So we have to focus that this is the axis that is locked to the structure. Okay, when I say